My friends, there are two types of the physical quantities. One is called the fundamental physical quantity and others are called derived physical quantity. So let us understand what do you mean by the fundamental physical quantity. Friends, whenever you want to describe or explain some physical phenomena or event taking place in the nature, may it be natural phenomena or it may be man-made phenomena. For example, how fast any car is or how fast the train is running. We are finding the speed of it. So speed is a physical quantity to explain the, you can say, whether the body is moving faster or slower. So that's nothing but the physical quantity, speed. How to find the speed of any person? We'll find out the distance traveled by that person or that vehicle, and we'll find out the time. And you know very well that speed is denoted as speed is equal to distance traveled divided by time interval. We'll understand how we are getting that speed is distance upon time. That's also we'll understand. But right now I am giving just an example. Another example, how long some you can say something is taking place or some physical phenomena is taking place. For example, how long are you studying? So in that case you are finding the time. So time is a physical quantity, and the primary measurement we decide to measure that physical quantity is called the units of physical quantity. For example, I studied 1 hour, so 1 hour is unit of it, right? In a second I can do this. That's mean 1 second. It means 1 second is nothing but what? A unit of physical quantity. So in the same way, there is distance traveled. So distance is measured in kilometer and it is also measured in meter, centimeter. So meter, centimeter, kilometer, they are the, you can say, units of physical quantity, distance. So let us understand, friends, how many you can say different physical quantities are there, and what are the fundamental and what are the, you can say, derived physical quantity. Here it is a list of fundamental physical quantity and their units. Let's understand what is the meaning of fundamental physical quantity. My friend, whenever you have to explain some physical phenomena or some events taking place in the nature or some man-made you can say events or phenomena, then we need to explain them by giving certain words or you can say terminology. Okay, so and that terms is to be measured, and their measurements is called the units. Okay, so what are the fundamental physical quantity? They are the certain minimum number of terms or you can say minimum number of the physical quantity. By deciding their units, we can derive the unit of any physical. They are called fundamental. For example, you want to measure speed, right? What is speed? Speed of any car, we are generally saying that 50 km per hour. So kilometer per hour, that is nothing but the unit of speed. We measure the speed of car in kilometer per hour. What is that? Kilometer is a unit of distance and hour is the unit of time. So here time and you can say length or you can say distance, they are called fundamental. So if you decide the units of fundamental physical quantity, you can get the unit of speed or such other physical quantity. So instead of deriving the or deciding the units of all physical quantity in physics, we have to decide the units of certain minimum number of physical quantity. If you decide their units, we can get the units of rest physical quantity. They are called fundamental. Is that clear? So these are 7 fundamental physical quantity, right, decided in SI unit system. So friends, what I have written over here, this is nothing but the SI unit system. Okay, in SI unit system there are 7 different fundamental physical quantity which is already listed on the board. I will explain them, I'll give the name of them and their units, and I'm writing the symbols of them. Okay, so let's say what is the first fundamental physical quantity? It is nothing but the length. So length is the first fundamental physical quantity. Its unit, the units of length, unit of length is meter. So this is the unit of meter and it is symbolized as, right, meter. Let's say we write as 5 meter, or we write 10 meter, etc. So we are writing length in this way. So meter is unit of fundamental physical quantity. Is that clear? Next is the second unit is the second physical quantity is mass. Its unit is kilogram. Okay, so unit of mass is kilogram, and it is symbolized as kg. Don't place a dot before or after g or anywhere. Just write down kg, and never ever write that 1 kg, but there are 2 or 3 or more kg. You will write down kgs. This is wrong. Don't write like this. Write in this way. For example, 100 kg, etc. Okay, this is the example of writing units of it. So this is 100 kg, etc. Next physical quantity, which is, you can say, fundamental physical quantity, is nothing but the time. Its unit is second. Next fundamental physical quantity is electric current. Its unit is ampere. Then thermodynamic temperature is the temperature, hotness or coolness, that's called the temperature. So temperature has unit Kelvin behind the name of scientist, Kelvin. Now then luminous flux, or you can say luminosity, luminous intensity, which is gives you the brightness of light. Okay, so its unit is candela. And the last one is quantity of matter. We will understand in more detail, right, regarding to this quantity of matter. You will also study that in chemistry. So this is nothing but its unit is given mole. I'm writing the symbols of every physical quantity. Time has unit second, electric current is measured in ampere, thermodynamic temperature is measured in Kelvin, and luminous intensity or flux is measured in candela. Finally, the quantity of matter is measured in moles. And their symbols are like this. Second is denoted writing S. It is simply write S. Then write simply A. Usually students are writing AMP for ampere. This is not correct, but you may write down that. No one will give you or no one will deduct the marks over here, but still you have to write down in a right way. Then next is Kelvin, and then next is candela, CD. The last one you will write down MOL. These are the symbol of every physical quantity. And using this, how we will find out the dimensional formula of any given physical quantity. Okay, let's understand by considering example. So my friends, let us understand or derive units of certain physical quantities, and then we'll derive the dimensional formula. So let's say I'm going to start from area. So the physical quantity is called area. Its symbol is A. So it is denoted by A. What is the definition of area? Area is defined as the product of length and breadth. Length and breadth. So equation of this is A equal to, here it is said product of length and breadth. So length is denoted by L, breadth B. So this is the equation of area. Is that clear? And what is unit of it? So distance is measured in meter, and this is also measured in meter. Therefore unit of area is meter square. You can see here there is no kilogram, there is no second, there is no ampere, or you can say Kelvin in this unit, only meter square. Next definition is, or physical quantity is volume. It is denoted by V. The volume of, you had already studied that the cuboid or cube is defined in this way. So volume is product of length, width and height. So equation of volume is length, breadth and height h. So what are the units of it? Unit of length is meter, unit of breadth is also meter, unit of height is also meter. So meter, 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 product of all these 3 meters, meter cube. So unit of volume is meter cube. Similarly, so what I am here want to explain you, you have to focus upon the definition. Whatever the given in definition, you have to convert that into equation. Here it is said product of length, breadth and height, that's volume. So we'll write down the equation length, breadth, height. So this is the volume. In the same way, let's understand definition of density. So density either denoted by rho or density by rho, and will denote density by d. Rho is also denoted, it is used to denote certain other physical quantities. So this symbol, my friend, remember it is rho. This is the symbol. What is the definition of density? Definition of density is mass per unit volume. In this definition, there are two physical quantity, mass and volume. So we write again volume, and here it is mass, right? Suppose you are taking two different bodies. The first you are taking 1 meter cube, 1 meter length, 1 meter breadth and 1 meter height, 1 meter cube water, and we are taking 1 meter cube iron, 1 meter length, 1 meter breadth and 1 meter height of the iron. We will measure their mass. Definitely their mass will be different. Let us take the 1 meter cube iron, you can say a cube of iron having 1 meter length, 1 meter height and 1 meter breadth, and we are taking a cotton 1 meter length, 1 meter breadth and 1 meter height. If we measure their mass, it is obviously we can see that the mass of iron will be more, because in 1 meter cube volume the density, or you can say there are large number of molecules of or particles of iron, as well as in detail that why every molecule has more mass, or you can say every atom of the iron has more mass, whereas cotton will have the less mass. So this is what called the density. So if we measure the V volume, what is the mass m per unit? So in 1 meter cube volume, what is the total mass? So this is denoted as rho is equal to 1 into mass, that is mass upon volume. This is the definition. And what is unit of rho? Therefore unit of density is unit of mass divided by unit of volume. You know, so density has unit kilogram per meter cube. That means kilogram meter raised to -3. So this is the unit of, you can say, density. So my friend, these are the three physical quantities whose definition and equation we know. Area, length into breadth, unit is meter square. The volume is nothing but this. What is volume? Volume is length, breadth, height. Its unit is meter cube. And density, unit of density is kilogram upon meter cube, or kilogram into meter meter raised to -3. So these are the three physical quantity we had studied. You may note down this as fast as possible. Hi friends, let us derive dimensional formula. It requires only 4 steps to derive dimensional formula of any physical quantity. And before I explain that, how to derive dimensional formula, and also will derive certain dimensional formula of many physical quantity here. Before that, let's recall something. You had already studied there are 7 different physical quantities in SI unit system. So what is SI unit system? It is system international, right? Internationally it has been decided there are 7 physical quantity accepted as fundamental physical quantities. What are those? Let's take the name of all them. So this physical quantities are 7 physical quantity. I am giving the name of them. This is physical quantities: mass, length, time, electric current, thermodynamic temperature, These are actually 5 physical quantity important to write down the dimensional formula. I will explain that how they are important. And other 2 physical quantity I am giving. What are the units of them? These are the name of physical quantity, and their units we are already knowing. What are they? They are kilogram, units of length is meter, unit of time is second, unit of electric current is ampere, and unit of thermodynamic temperature is Kelvin. To write the dimensional formula, we need 5 different symbols, or 5 different, at least you have to remember. So what are those? Here next 2 physical quantities are this. One is quantity of matter and luminous flux. I am giving the units of the quantity of matter is measured in mole, and this is in candela. So normally we are not using, or they are not physical quantity we are having in 11-12 standard, right? It requires this dimensional formula, in dimensional formula. Sometimes we are using mole also. We'll think about it. What are those physical quantity? Here, these are very important. M stands for mass. In dimensional formula we will use M. It stands for mass. We'll use L, length. It stands for the length, or showing the unit of length in unit of any physical quantity. This is the T required to write dimensional formula. We need A. It stands for ampere. We'll use it. And in some physical quantity require Kelvin. Suppose there is temperature unit Kelvin in unit of any physical quantity. So these are the 5 different you can say symbols we will use to write down the dimensional formula. So at least you have to remember this. Mass as unit kilogram, length as unit meter, time as unit second, electric current as unit ampere, thermodynamic temperature as unit Kelvin. Understand? These are the things you have to remember. Let us go to how to find out dimensional formula, and what are those 4 different steps as I said to derive dimensional formula of any physical quantity. Let's see. So these steps are this one. I am going to remove it. The first step to derive the dimensional formula of any physical quantity is this, my friend. In every case, to understand even entire physics, this is always required that you have to understand definition of any physical quantity. So the first step is definition. Understand the definition. There are certain wordings of definition. You have to use that wordings or the statement, right, which defines certain physical quantities. So first thing, understand definition. Second thing, using definition you have to derive equation, or we are saying formula of any physical quantity. Formula. And next step, using this equation we will write the units of that physical quantity, unit of that physical quantity. Understand? We will use the fundamental units to derive the unit of any physical quantity. So these are the it is a use of unit, and then we can get dimensional formula. And before I explain what is dimensional formula, I have to derive it. I have to explain it or define it. What is dimensional formula? See, dimensional formula is nothing but this. Dimensional formula. It is an equation or formula which gives relation between unit of a physical quantity and units of fundamental physical quantities. So if someone asks you what is the what do you mean by the dimensional formula, or what is the definition of dimensional formula, it is this. It is an equation, or you can say formula, which relates the unit of one physical quantity with the unit of fundamental physical quantities. So this is the meaning of dimensional formula. You will understand better when we are going to derive the dimensional formula of any physical quantity. Understand? So these are the 4 steps, very important, my friends. First, understand the definition. Using this definition, derive formula of physical quantity, then get the unit of it, and then dimensional formula. Let's start with the dimensional formula of very simplest physical quantity, right? It is speed. So let's understand what is the meaning of speed and how to get the dimensional formula of any physical quantity. Listen, my friend, speed is nothing but the distance traveled by any particle or body in unit time. For example, a car travels 100 km in 4 hours. It will be already known to us that speed is defined as distance upon time. But how does it defined in this way? Actually, we are finding the speed of body by finding how much distance does the body cover in unit time. Unit time, suppose we are taking in day-to-day life, the speed of car or motorbike or any vehicle, we are measuring in kilometer per hour. So if a car travels 100 km in 4 hours, its speed will be in 4 hours. Here I am writing the time. This is the time, and in 4 hour time, car travels how much distance? We say distance traveled by car is 100 km. So in unit hour, in unit means 1. So in 1 hour, how much distance does it travel? This is 100 by 4. You are finding 25 km per hour. So this we are already knowing from 8th standard, 9th standard, 10th standard. We had already studied it. But let us take a view or how to get the equation from this definition. So first of all, I will write down the definition of speed. Then we are going to find out its equation, and then using equation we will derive dimensional formula. Let us study the dimensional formula. Let us derive the dimensional formula of any physical quantity. I will start first from the speed. You know, from childhood or from 8th standard, 9th standard, already you are knowing speed is defined distance upon time. But let's see here in detail how we find the speed. Here, definition of speed is this. I am going to write down the definition of speed. What is speed here? Speed is defined as speed. Its symbol is V, right? This is a symbol of it. Speed is defined as the distance traveled by body. It may be any vehicle or anything, body. Here in physics we will write particle, right? Why? We will understand the concept of particle. So body in unit time. So this is the definition. Now using this definition I am going to derive how to get the dimensional formula, you can say equation, and from equation the dimensional formula. See, there are two different physical quantities in this definition. The first physical quantity is this distance, and second physical quantity is time. So we will write down them in this way. It is asked that how much distance has been traveled by body in unit time. If you are taking SI unit, 1 second. If you are taking day-to-day life, we are measuring speed in kilometer per hour, so that will be 1 hour. As I said you, one example that 100 km in 4 hours, so in 1 hour it is 25. So similarly here, We'll write down here time, and we are writing here distance traveled by body, distance. Suppose in I said 4 hour 100 kilometer, or I can say 4 second 100 meter, 10 second 1000 meter, whatever it is, whatever the time would be there, whatever the distance traveled by particle. So that's why we symbolically write in time t, suppose distance traveled by body is d. So in 1 second, that means in unit time, how much distance traveled by body? This is a question mark. So 1 into d, that is d upon time. So this is the equation of speed. So speed is equal to distance upon time. This equation we get from this definition. Now how to get the dimensional formula of any physical quantity? First we will write down the unit of it. See, speed v equal to distance d upon time t. So therefore unit of speed equal to unit of distance divided by unit of time. So this is the how we write it. So therefore unit of speed, what is unit of speed? Unit of speed v equal to unit of distance. Already we know that distance is measured in meter in SI unit system. So meter upon unit of time. You know very well unit of time is second. So this is second. So or it is also written in this way, meter second inverse. So meter per second or meter into second inverse is the unit of speed. Now how to write down the dimensional formula of any physical quantity? Before I explain that, you note down this. So my friend, we had already studied that how to find out the unit of any physical quantity. Now I am going to explain you the dimensional formula, how to write down the dimensional formula of speed. So let us check over here how to write down this. See, unit of speed is meter per second or meter second inverse. To write dimensional formula, we need this. This is a symbolically how we write. The square bracket V means dimensional formula of speed. Square bracket V means dimensional formula of speed. So how to write down the dimensional formula of speed? Let us check here. So square bracket V, dimensional formula of speed. We will write down over here mass, length, time, and if there is electric current, we will write down ampere and Kelvin if temperature. But there is no ampere, so I am not writing over. Let us check. What is the power of meter in unit of speed? Power of meter is no unit, that means it is meter power 1, second power minus 1. So this is the power 1, second power minus 1, so this is minus 1. Here we can say, is there kg over here? Is there kilogram over here? There is no kilogram. That's why you can say kilogram has power 0. So there is 0 power of kilogram. So we'll write down the 0 power of mass. So mass power 0, length power 1, time power minus 1. This is how the dimensional formula. It is found, or it is said that if someone asks you, what is the dimension of mass in speed? So we can write down over here dimension of mass in speed is 0. This is the dimension. Similarly, dimension of length in speed, it is 1. Here it is power 1. Similarly, if someone asks you what is dimension of time, dimension of time in speed, so dimension of time in speed is minus 1. So, what is dimension? If someone asks you what is dimension, I am going to derive the or you can say define the dimension of any physical quantity. What do you mean by dimension over here in dimensional formula? Hi friends, we had studied what is dimensional formula, but what is the use of that dimensional formula? Let's understand that in dimensional analysis. So if someone asks you what is dimensional analysis, let's understand that first. The word dimensional analysis. If someone asks you what is the meaning of dimensional analysis, the answer is if we are using dimensional formula to solve certain problems in physics. So there are a lot of problems in physics. If we use a dimensional formula to solve such problems, then it is called dimensional analysis. So let's write down the answer of this. If we use dimensional formula to solve problems in physics, it is known as dimensional analysis. So this is the answer of dimensional analysis. There are, you can say, three uses of it, or there are three kind of the problem we can solve, or you have to study in Newton standard three types of the problem. The first, in dimensional analysis, we will understand how to find relation, we can say equation of a physical quantity with other physical quantity. So this is one of this. For example, I am writing kinetic energy is half mv square. So how does kinetic energy associate with velocity? What is the equation of kinetic energy in terms of the mass? How does the kinetic energy depends upon mass? This kind of relation we can find out. This is the first. We'll solve number of problems using this, right? How to find out the relation, or you can say equation of one physical quantity with other physical quantity. This is first. The second thing is we can check whether the equation we got is correct or not. So second use of it is to check validity of any equation. To check the validity of any equation. For example, I am saying that electric field is kq by r square for single charge particle, or if we have the potential energy u equal to mgh, that's an equation of gravitational potential energy. Whether it is correct or not, we can check the validity of this equation using dimensional formula. So that's a part of also dimensional analysis. The second and the last one is this. The next and last one is this. What is the relation between unit of one physical quantity in one unit system to the another unit system? So let's write down that. To find relation between two units of a physical quantity in two different unit system. Is for example, we know that 1 kilogram is 1000 gram. So this is the first relation, that 1 kilogram is 1000 gram. You know, gram is unit of mass in CGS and kilogram is unit of mass in MKS or NSI system. So 1 unit of mass in SI system is 1000 unit of mass in CGS system. Similarly, 1 unit of pressure in SI unit system equal to how much or how many unit of pressure in CGS This kind of relation we can find out. Like Newton is a unit of force. So 1 Newton is how many unit of force in CGS unit system or other unit system. This kind of relation we can find out. This is the meaning of dimensional analysis. We will first start with this one, that how to find out the relation of one physical quantity with other physical quantity by taking the examples. Friends, now we are going to understand the first step or first use of dimensional analysis. What was that? How to find out the relation between one physical quantity and other physical quantities. So let's find out that. One of the example I am taking is the periodic time of an oscillator. So let's consider one oscillator, or you can say pendulum. So this is the rigid support and this is the bob, or you can say sphere, suspended by means of a thread. Now it is nothing but a simple pendulum. Now it is displaced slightly and release. So it is displaced angularly in this way and release. What will happen? It will start to oscillate, right? So one oscillation, while it goes over here on another end and comes back to the same end, that's called one oscillation. So after completion of one oscillation, we will calculate what is the time to you can say complete one oscillation. That's called the periodic time. And if someone asks you that periodic time of oscillator, periodic time T of oscillator, or you can say pendulum, depends upon this length of pendulum. Total length is from rigid support to the center of sphere, center of mass of the sphere. So this is the total length of pendulum. So it depends upon length of sphere L. It also depends upon acceleration due to gravity G. If it is given like this, also it is given, suppose its angular displacement is more, we can think that instead of this angle, if it is released from this angle, then it may possible that it may have more you can say amplitude or more larger oscillation. It may take more time, that we can think. So let's understand, or let's take this. It depends upon this angular displacement, say it depends upon angle theta, and also it depends upon, if it is massive body, it may have the certain oscillation or motion. So you know, we can say it also depends upon mass m of this oscillator. So what is the exact relation between periodic time T and all this physical quantity? We don't know. How does periodic time depends upon mass? It quite possible it depends upon m power 1, m power 2, m power root, or you can say m power 1 by 2 or 3 by 2, whatever it is possible. It also possible that T proportional to L power 2 or length power 2 or L cube, or whatever the relation is possible. We don't know right now. Let's derive it. So what will you do here? We are not knowing the powers of this physical quantity upon which periodic time depends. So that's why you have to write down the equation number 1 in this way. According to the given information in question, that T proportional to L power A, G power B, M power C, theta power D. And when we remove this proportionality sign, we place constant. Let's say constant K. L power A, G power B, M power C, theta power D. Say this is equation number 1. So your first step is to obtain the equation number 1. How to get some physical quantity depends upon other physical quantity. And you will you can say imagine, or you will think certain names of this proportionality powers of this physical quantity upon which this depends. So x, the physical quantity, depends upon other y, z and other p, q, r, l, m physical quantity. You don't know what are the powers of it, so you will write down the unknown powers. Your job is to find out unknown powers. So while you are going to remove this proportionality sign in an equation, you have to write down a proportionality constant. So let's say T equal to K proportionality constant, L power A is unknown power, G power B, M power C, D power theta power D. Now, is it necessary that you should consider power A, B, C, D? No, you can consider X, Y, Z or whatever it is, right? You have to just find out, write down the name unknowns, and these unknowns is to be obtained. Second thing is this proportionality constant. Is it necessary you should always write K? Answer is no. It is not necessary to write down K. You can write down any name. You can write down C. You can write down X, whatever it is. So it's just a name of these symbols. Understood? Let's find out what is the next step. After placing proportionality constant in equation, you will write down that equation number 1. Now next step. So first step is derive or write down the equation number 1. Okay, get the equation number 1. Second step, my friend, is replace all physical quantity in equation by their dimensional formula. So let's say, what are the dimensional formula of it? So dimensional formula of periodic time, as unit is second, dimensional formula will be m0 L0 t power 1. Dimensional formula of length, as its unit is meter, it is m0 L1 t0 because there is no second. Acceleration due to gravity, as it is acceleration, unit is meter per second square. So dimensional formula will be m0 L1 t minus 2. In the same way, theta is nothing but unit of theta is radian. Radian, according to definition, it is arc upon radius. Arc is length, radius is length, so it has no unit, and that's why this is m0 L0 t0. And last one, it is mass. Say it is nothing but unit of mass is kilogram. That's why it is m1 L0 and t0. Say this is equation number 2. Now your job is use this equation number 2 in equation number 1. That means replace all this dimensional formula, all this physical quantity by this dimensional formula. So I am going to replace, or I am going to substitute all dimensional formula right in the equation number 1. So let's write down the first. We will write down m0 L0 t1. What about K? Here always remember that in this method you have to consider the proportionality constant is dimensionless, and remember this, we will consider this as a limitation of dimensional analysis, right? So what is this limitation? That you don't know what is the unit of proportionality constant, right? So here K is to be considered as dimensionless. So I am writing over here K dimensionless physical quantity. So K has no unit. Now unit of length, we will write down m0 L1 t0 power A. Second bracket, acceleration due to gravity, m0 L1 t power minus 2 power B, and mass m1 L0 t0 power C. And last one has no dimension, m0 L0 t0 power is nothing but D. You know, the simple mathematic is this, right? Whenever it is power of power, you will multiply it. So here it is m raised to 0 into A, so that will be m raised to 0. So can I write down this equation again? m0 L0 t1 is equal to this. I will write down this is m0 L power A t power 0 multiplied by next minus 2 L raised to 1 into B, that is L raised to B. So can I write down this is m0 L raised to B t raised to minus 2B, as there will be the product of 2 and B. Now m power 1 into C, so that's why it will be m power C L power 0 t power 0. So next is m power C L power 0 t power 0 multiply by all m0 L0 t0 multiply by D, so it will be gone. So I am not writing it, or you can also write down this no change L0 t0. Now let's simplify this equation. You just have to find out the unknown powers A, B, C. So here it is m power 0, here it is m power 0, m power C, and so there will be, as there is, you can say, product of all as same base and powers will be added. So can I say 0 plus c? So that will be L power c. Now L power a, L power b, so a plus b, and here it is L power 0, so L power 0. So there is no L power a plus b we got. Now last one, t power 0 plus t power minus 2b, t power 0, t power 0. So this will be minus 2b. Now let's see equation number 3 suggests us that. What does equation number 3 suggest us that? Left hand side dimensional formula equal to right hand side dimensional formula. And this is possible if their powers are equal. That means m power 0 equal to m power c. So what does it mean? From above equation, if we compare powers or indices, what we can say? C equal to 0, first equation. Second equation you are getting a plus b equal to 0. The last equation you are getting 1 equal to minus 2b. So from the last equation, what you can say? B equal to minus 1 by 2. So we got the first answer or first unknown, b power minus 1 by 2. Now we can use this in equation, this a plus b equal to 0. Therefore, a plus b equal to 0, it implies that a minus 1 by 2 equal to 0, and that gives you another value, what is of the power out of a, b, c, d, that a equal to 1 by 2. What will you do now? Whatever the powers you got, a plus a, b, c, d, you will place that powers in equation number 1. So using this value in equation 1, using these values in equation number 1, what will you get? That equation 1 suggests us a t equal to k L raised to, what is the power of L? A. So a equal to 1 by 2. Then it is acceleration due to gravity. G, its power is b. What is power? Minus 1 by 2. Minus 1 by 2. Mass power c, 0. And automatically theta cancel out. So one thing is to be remember over here. If you are finding a relation of a physical quantity which has no dimensional formula, or theta has no dimension, that's why the relation of t and theta cannot be obtained, because m0 0 t0, the power will be automatically gets cancelled. So anything raised to 0 is 1. So m raised to 0, that is 1. So ultimately what are you getting over here? You are getting that t equal to k L raised to 1 by that root, and into 1 upon g raised to 1 by 2, that is root. That means t equal to k square root of L by g. Understood? This is the equation. You may write down, you will get the full marks if you are writing this t proportional to root L by g, because you don't know what is the you can say value of k. But if you know it, it sometimes given that, prove that, sometimes it is given that, prove that t equal to 2 pi root L by g. You got root L by g, and it means that k would be have the value of 2 pi. So that we can write down over here if it is given. If it is not given, it's okay, right, in beginning of 11th standard. After 12th standard, or before you complete your 12th standard, or before you complete the 11th standard, you will get the equation, and you will able to understand what are the values, or you will get the values of this kind of proportionality constant. So don't bother about it right now. Just write now that t proportional to root L power g, you will get full marks. Otherwise, if you know it, you can write down t equal to 2 pi root L by g. So you got, student, this is how we can find out the relation between one physical quantity and other physical quantity. This is one example, and you may write down this example if you want to write. I will discuss another, right, you can say example, how to derive physical quantity has a relation with other physical quantity. I will derive one another equation. What is that? Relation of one physical quantity with other.